Welcome back to the Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm joined by the brilliant Victor. Before we dive in, I want to remind our listeners that your ratings and reviews really help us reach more people. So if you're enjoying the show, please take a moment to rate us on your favorite podcast platform. Now, let's get into today's topic.
Thanks, Sheila. Today we're continuing our journey through Chapter 3 of Season 1, where we're exploring distributed hash tables, or DHTs. We've already covered the concept and purpose of DHTs, as well as the put operation. Now we're going to dive into the get operation.
Excellent. But before we start, I have a tricky quiz question for our listeners. Here it is. In a DHT, if a node doesn't have the requested data during a get operation, does the operation fail? Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a great question, Sheila. It really gets to the heart of how DHTs operate. I'm sure our listeners will be pondering that as we go through the episode. It's not as straightforward as it might seem at first glance.
Indeed. Now let's start with the basics. Victor, can you explain what exactly the get operation is in the context of DHTs?
Certainly. The get operation in a DHT is essentially the process of retrieving a value associated with a specific key. It's like looking up a word in a dictionary, but instead of flipping through pages, you're navigating through a network of distributed nodes.
That's a great analogy. So, if I understand correctly, when we want to retrieve some data, we use its key to find it in the DHT. But how does this differ from the put operation we discussed earlier?
Good question. While the put operation is about storing data in the DHT, the get operation is about retrieving it. Think of put as hiding Easter eggs and get as finding them. In put, we're deciding where to place the data, but in get, we're following the trail to find where that data has been hidden.
I love that Easter egg analogy. It really helps visualize the process. So, can you walk us through how a get operation actually works in practice?
Absolutely. When a node wants to retrieve data, it starts by hashing the key of the data it's looking for. This hash determines which node in the DHT is responsible for storing that data. The requesting node then sends a message to the closest node it knows of to that hash value.
Interesting. But what if that node doesn't have the data?
That's where the beauty of DHTs comes in. If the node doesn't have the data, it doesn't mean the operation fails. Instead, that node will forward the request to the next closest node it knows of to the hash value. This process continues until we reach the node that actually has the data, or until we've determined that the data doesn't exist in the DHT.
Wow, that's clever. It's like a game of hot and cold, getting closer and closer to the data with each step. But doesn't this process take a long time if we have to go through multiple nodes?
That's a great observation, Sheila. In practice, DHTs are designed to be efficient. Most DHT implementations can locate data in what we call O log n steps, where n is the number of nodes in the network. This is achieved through clever routing algorithms and maintaining routing tables at each node.
O log n? That sounds efficient, but can you break that down for our listeners who might not be familiar with big O notation?
Of course, big O notation is just a fancy way of describing how the performance of an algorithm changes as the input size grows. In this case, O log n means that as the number of nodes in the network increases, the number of steps needed to find data grows much more slowly. For example, in a network with 1 million nodes, you might only need about 20 steps to find your data. It's remarkably efficient for such a large distributed system.
That is impressive. Now I'm curious about real-world applications. Where might we see get operations in DHTs being used?
Great question. One of the most well-known applications is in peer-to-peer file-sharing systems like BitTorrent. When you're trying to download a file, your client performs get operations to find peers who have the pieces of the file you need. Another example is in distributed databases, where get operations are used to retrieve data from across a cluster of machines.
Fascinating. Are there any common challenges or edge cases we should be aware of when it comes to get operations in DHTs?
Absolutely. One challenge is dealing with churn. That's when nodes join and leave the network frequently. This can sometimes lead to outdated routing information, causing Get Operations to take longer or even fail. Another issue is handling malicious nodes that might try to return incorrect data or disrupt the routing process.
Those sound like significant challenges. How do DHT implementations typically address these issues?
There are several strategies. For churn, many DHTs use periodic routing table updates and have backup routes. It's like having a GPS that constantly updates its map. To handle malicious nodes, some implementations use data replication across multiple nodes and employ verification mechanisms to ensure data integrity. Think of it as getting a second opinion to confirm the information you received is correct.
That makes sense. Now, as we're nearing the end of our episode, let's circle back to our quiz question. Victor, would you like to reveal the answer?
Certainly. The answer is no. The GET operation doesn't necessarily fail if a node doesn't have the requested data. As we discussed, the request is forwarded to other nodes until the data is found, or it's determined that the data doesn't exist in the DHT. This routing process is a key feature of DHTs that makes them resilient and efficient.
Excellent. To summarize today's episode, we've learned that the GET operation in DHTs is used to retrieve data based on a key. It works by hashing the key and routing the request through the network until the data is found. We've seen how this process is efficient, typically taking O log n steps, and how it's used in real-world applications like P2P file sharing. We've also touched on some challenges like churn and malicious nodes, and strategies to address them.
That's a great summary, Sheila. I hope our listeners found this deep dive into GET operations in DHTs informative and engaging.
Thank you, Victor, for your insights today, and thank you to all our listeners for tuning in. If you enjoyed this episode, please don't forget to rate us on your podcast platform. You can also visit crashcasts.com to join our Discord community or support us on Patreon. Your support helps us continue creating this content. Until next time, happy coding.